Welcome to another video. So this is a question on mole concepts. I want to solve this question. The question goes thus: calculate the mass of potassium tetraoxomanganate 7 that has to be dissolved in water to prepare 100 cm cube of a 0.02 molar. So what I'm going to do here is not far-fetched. So I need to write the formula of that compound. So the formula of potassium tetraoxomanganate 7 is KMnO4. So potassium, the atomic mass of potassium is 39, of manganese, that is 55, then of oxygen, that is 16. So let's work with this. So that is potassium is 39. Let's find the molar mass of this compound, KMnO4, plus 55 plus 4 times 16, because that of oxygen is 16, that is 64. So let's try and compute this. Let's try to compute this. If you compute this, 39 plus 55 will definitely give, that is 94. 94 plus 64, that is 158. That is 158 gram per mole. So the molar mass of that potassium tetraoxomanganate 7, the molar mass is 158 gram per mole. So the next line of action is to write the parameters of the molarity. So the molarity is equal to 0.02 molar. Then the volume of the solution, the volume is signified as 100 cm cube. So I only need to convert from cm cube to what? To dm cube. If I convert from cm cube to dm cube, I will divide this by 1000. So that will give me 0.1 dm cube. So I've successfully converted from cm cube to dm cube. And in our mole concept, if we remember a particular formula that connects concentration with volume, with with concentration, volume, and number of moles. Yes. So I know that number of mole is equal to concentration times volume. N is equal to Cv. This concentration is also the what? The molarity. So now I can find the number of mole of this compound. So the number of mole is equal to, our concentration is the molarity, and our molarity is 0.02 multiplied by, now the volume is what? The volume is 0.1 dm3. So when you compute this, the number of moles is 0.002 moles. So the number of moles of that compound is 0.002 moles. Now the next line of action, since we've known the number of moles to be this, there is a connection between number of moles, mass and molar mass from our mole concept. I know that the number of mole, N is equal to mass over molar mass. So the next line of action is to isolate mass. I'm going to isolate mass. That is, I'm going to make mass the subject of the situation. So mass is equal to number of mole N multiplied by what? Molar mass. So mass is equal to, the number of mole in question is 0.002. Then multiplied by the molar mass of the compound is 158. So when you compute this, that is 0.316 gram. So the mass required is 0.316 gram. So the mass of potassium tetraoxomanganate 7 required to dissolve in that volume of water is 0.316 gram. So life is continuous. Life is differentiable, is integrable, but not the best measurable. It is a light.